Hi, welcome everyone. In this video, I'm going to show you how to estimate differences estimator in Stata. For that, we are going to load a specific code file that I'm going to show it here, and then the output will be shown in the background, and I will discuss on the way. So the for the differences estimation, the data has a specific characteristics. First of all, it can have many cross sections, but the cross sections can be divided into two major groups. One group where the treatment has been applied, and another is where treatment has not been applied. It can be specific characteristics like developed country groups or developing country groups, and it has two different cross sections, two different time periods. So in the data, there can be many years, but the years can be divided into two groups. One is before the treatment, or another is after treatment, or other way around if the treatment comes first. Okay, so this way you have two binomial variables dividing your cross sections into two groups and time period into two groups. Then you create the difference in differences variable, which is just a cross product of these two variables, which will make it the common thing, that is the countries which are treated and the time periods in which the treatment was applied. So here I will read the data from the Excel directly using this command: import Excel, the directory, sheet name, and cell range, and the first row has a variable name. So I loaded the data. I will show you the variable names. So this is the simple data where I have some countries, their code here, broad money data, GDP, and CPI. So it's just a macroeconomic variables. So I will create the other groups in these codes in front of you. So here, first of all, I will encode the country as a ID so that the data is coded. Then I will convert the time period into two groups, which is pre and post COVID. So it will divide the data into two groups. And if you open the data set, you will see that there is ones and zeros as a data. So this divides the here data into two groups. Then just for simplicity, what I did that I wrote the list of countries which are developed countries and create a local temporary data file, a temporary memory. So it has loaded these variables. Then I wrote a code about that. If they create a new dummy, which will be equal to 1 if the country name in my data set is equal to any of the country names here. So I will use this, and when I run this, it will create a new dummy which will be equal to 1 if the country is this, otherwise 0. So you can use it without loading this local, because the code was there to reduce the complexity of the codes, but I made this one also, so you can work without this code. So if I open the data file, you can see it here that I have another variable which is equal to 1 when the country is developed and 0 when the country is not developed. So I have a treated cross section variable which is dividing my cross sections into two, and my time period variable which is dividing my years into two groups. So I have what I need. Run the run the differences estimator. But first of all, what I will do is I will generate the did variable, that is just a cross product of the two dummies, create the log of the variable that I need. Then what I will do is that I will run the regression. For that I need dependent variable, independent variables, the did variable, the binomial variable that is defining the two groups, and the binomial time variable which is defining the two time periods. So when I run this, it will show me the effect of did 1 versus 0. So it is significant here. So it is showing that the BM will increase in 1 as compared to 0. So that treated groups in treated time period are showing higher effects. So it can be shown here. So E stat trend plots. So when I run this, it will show me a plot. So you can see it here that the intercept is higher for the treatment groups post-COVID, as the intercept is higher for the treatment groups and the slope is also higher for the treatment groups. So it means that they, as an intercept, they look parallel, but if you compare their slopes post treatment, the slopes are also changing. So this way you can show the treatment effects of your variables. You can also change the labels by start graph editor, and you want to write the full names of the variables or the treatment effect treatment name that you want to edit here. So it can be edited from this button. So this way you can show it. But if you want to do some other tests, so what you can do is you can run it again, but change the variables from the binomial cross section to continuous cross section and binomial time period to continuous time period. It when you run this, it will give you a different outcome because now there are it is now measuring cross sections into many groups and time periods into many time periods. Now you can do a test on it, that is parallel test for, so parallel linear trends are parallel, so it is not significant, so it is not parallel, so it means post COVID the slopes are changing. And then you can do the Granger test. So no effect in anticipation of treatment. So it is significant. So there is an effect. Okay. In the P trends, it was insignificant. So it was saying that it was parallel. Null hypothesis was accepted. Here it is saying that there was some effect. It is significant. Then you can also do this with further robustness. So it will run like this using VCHC2. Then you can do it for panel data if your data is panel data. So our data is already panel data form. So I will do xt set ID and year. Then do the same command which was shown in line number 43. So xt PID regression. So it gives significant outcome. Okay. And then you can do the plots here again. It is showing same outcomes. So this is the way you can do DID regression, differences regression in Stata. Thank you very much for watching.